Okay, let's talk through design task number 3, where to put a new community pool. So here is the map with all the data layers turned on, and then here is the link to open the map in the new window. We'll go there in 1 second. And then these are some instructions of what to do as you go through. So looking at the map and executing the instructions, but with some added reveals on how to approach it. First thing we recommend you do is switch off all the layers, right? That they're all switched on to start with, but that's to show you that there's too much to deal with. So this is just the Philadelphia boundary layer, not a big deal. This is the current Philadelphia Parks and Rec community pools. So if you click on one, you get some information about it. Then we have a polygon layer of population density. And to see what the colors mean, don't forget to hit the legend. And sorry, this isn't population density, median household income. Green means more money, blue means less money, gray is in between. So let's keep chugging. So turning off median household income, getting to population density. So again, what do the colors mean? We go to the legends, and green means more densely populated, and purple means less densely populated, with gray in between. We then have Philadelphia Public Schools, elementary and middle only. Note that this layer has been filtered. So if I click on the filter, you can see that grade range is not 9 through 12, so not high schools. It's all the schools that are below that. And then we have childcare centers located in Philadelphia, so all over the place. Again, click on them, get some information about it. And then finally, these are the zones that the task for the students is to decide which of these 5 zones should get a new community pool. And if you click on the zones, you get a little pop-up saying that's the yellow one is northwest and the green one is northeast. We're going to call this west and central, and the purple one down here is south. So how to structure the work with this? Well, you can say, let me look at where are there lots of people, right? And then let me look at where are there current pools, because it would make sense to put the pools where the people are. Right now, this population density layer is on top of the pools layer. So what I'm going to suggest we do is pull this layer up and then let it sit on top so you can see it a little bit more easily. And so you can look around and say, well, I see a lot of green here in South Philly and a little bit here toward the center, but there's also a lot of pools around there. Do I need to add another one there versus there's some green over here in West Philadelphia and some pools, but what's the ratio? Or in Northeast, I see some green that has no pool on top of it, but there's other pools that are close. So you could say would make sense to put it where the people are, but you also probably want to focus on children. So where are the children at? So we don't have an exact version of population density that would have only, people under the age of 18. But I can use schools, and again, filtering schools for the elementary and middle schools to use that as a proxy for where I might find students. And indeed, you can see there's actually a correlation between these schools and the more densely populated parts of Philadelphia. So if we just look at schools as compared to where the current pools are located, you could start to think about, oh, well, I've got, this big zone right up in here, lots of schools, but no pools. But before you let students get too far down that road, think about the fact that children are in, when will they most likely use the pools in the summer? Where the schools are located is where children are in the non-summer months. So, these two data sets are not necessarily tracking children's location at the same time of year. That there's going to be if nothing else, there's a rival risk consumption problem. You're either in school as a child or you're at the pool. Could be different geographies for this. So what if we try out not public schools, but childcare centers? And so we see these are scattered all over the place, and there's so many of them. It can be kind of hard to really get a sense of where should we look. So we're going to use one of the built-in GIS tools here called clustering. So we're going to take child care centers, and then I'm going to go over here and pick up this tool right here, aggregation, and enable aggregation. And so what this is doing is it's drawing, if there's seven, like right here, there's 17 child care centers in close proximity. It draws them into one big dot on the map, as opposed to like here is one isolated little dot on the map, because that's a child care center all by itself. Oh, and that one happens to be at an elementary school as well. So we can increase the level of clustering to simplify the analysis. So as I do this, it's giving itself like a bigger and bigger buffer around the center point of a bunch of childcare centers to make a bigger and bigger cluster. So now I have very few of these singletons, right? I just got a singleton right there, and then everything else around it is one of these bigger clusters. All right, so if we cluster the childcare centers, does that let us start to pick at the pattern here? And well, maybe. Why don't we also cluster the pools? So if I click on this and go back to aggregation, enable aggregation, and now I can cluster up the pools again, increase the clustering level. Okay. So now we've got a lot fewer points. We can start to think about it. And if you overlay the zones on top of this, you can actually start to calculate averages. So for example, we could say, let me just go down here into South Philly since it's the easiest spot, that, I've got 6 pools, plus 2 makes 8, plus 1 makes 9. All right. And then I've got 2 child cares, 53, 55 altogether, then 66, and then 69. So you've got a ratio of 69 child care centers to 9 pools. So that is going to be a ratio of about 7 to 1. All right. And then do the same math in the center, do the same math in the west, do the same math northeast, northwest, to see where is the greatest ratio of child care centers to pools, and therefore where might be the greatest need. What you're going to find is that northeast and west have the largest ratios. And then if you have to pick as a tie break between those two, I recommend that you take a look at median household income. That once you do that, okay, you can see that Northeast Philadelphia here is a lot wealthier generally than West Philadelphia. That's this is mostly above the median for the area, and this is mostly below. So that would suggest that you would want to add in a new community pool somewhere here in West Philadelphia. And that is how we can approach design task number 3.